All right, let's start. We will briefly learn about how we can use the shellcode. So now you know how to write the shellcode, and then that shellcode run like a get EGID, set regid, and the exact V for you. And then next step is like that we need to learn about how to inject that kind of shellcode into the program's memory space, and then use that. So the recap about the shellcode. So in the real attacks, so I believe I'm just recording. Yeah. So the recap about the shellcode in the real attack cases, you will never have the get a shell function like functionality. Sometimes there is. So like I previously worked on the hacking on the Samsung's television in like the 2005-6-ish. So it's over like the NDA period, so I can tell. So like that there were like the some of the functionality that uses the system functions a lot. And then there are a lot of functionality about like the running shell command as like the in the C program, they use it like a script language or something. So they are running lots of shell commands. So it's relatively easy to like just invoke that function, then it will run the shell command. So that there were some of the cases, but in the most of cases, they do not have like a system exec VE if there's no reason to execute another program. So for example, think about the Google Chrome. So think about their JavaScript engine. So there will be no need to running another program at all. So in that case, they will never have like a system or exactly those kind of functionalities in the code space. But we can always inject our shellcode because those system calls are available as operating systems API. Yeah, so we can always call that. So the topic for today is like how can you use the shellcode? Yeah, and then these are like some of the information for that. And let's take a look at the how we can execute our shellcode. So for the buffer overflow attack, we just build a buffer, and then suppose we can directly change the return address. Then you want to put the address of the shellcode, then CPU, they don't care whether it's data or code. So I told you about the von Neumann architecture. So all our computers are now von Neumann architecture. Code and data are all in the same memory. So like we can run on that. But the one interesting thing is like starting from 2003, when AMD 64 comes in, so the entire data structure enlarged 2 times from the 32-bit to 64-bit. So like that they do have a lot of like free spaces. And then previously, we do not have a permission bit for executable and non-executable for the memory. Yeah. So if you take my CS444, you might have take a look at the 32-bit page table. We don't have like the executable, non-executable bit in the page table. But in the 64-bit architecture, the bit number 63 in the page table is called as an NX bit, no execute. So if that is up, then the CPU will ignore that from the execution. So shellcode execution need to overcome a little bit more hurdle in that case. But at this stage, I did not set any of that so that you can run on your shellcode. So the next challenge is that after writing the shellcode, you want to know how can you put the shellcode and then run on the shellcode. And to do that, we need to get the address of the shellcode. How can you do that is, so the first thing is, so we are writing into the buffer. So one of the places that you can put your shellcode is the buffer itself. So we will fill the buffer from here to, maybe I can use the laser pointer, from here to there. Then suppose your shellcode is short in maybe like 30 or 40 bytes, then like it's definitely less than the 128 bytes. So some of the challenges allows you to have a buffer 128 bytes. Then you can put the shellcode here, and then overwrite up to save the UP, and then put the address of shellcode. Actually, the address of the start of the buffer. Then you can run on the shellcode. Any questions for that? So this code snippet actually gives a demonstration on like how you can send that kind of buffer. So buffer will be filled from the start. So just put your shellcode, and then padding is like the lengthwise. We need to fill up the buffer, then fill the saved ABP with the random value, and then fill the address of the input itself. And then how can you get the address of the shellcode is like you can use the debugger GDB. Yeah, and then you can always check like where is the EBP minus 0x80 or 88. Then you can get the exact stack address and you can put that address. That's the one way of putting the shellcode. So the first challenge called the Stack Overflow, SC is for shellcode and then 32. So this challenge kindly lets you know about where your buffer is at. Yeah. So what you need to do is like the insert the shellcode, and then at the end of the return address part, put this address. Yeah. And then to do this, you want to use Pawn tools to read some of the output of the program. So previously we used send line to send the line to the program, but if you call receive line, then you can actually read these kind of a message and then split with the colon and then get the second element. Then you can easily get this kind of a hexadecimal string and then change it to the integer. Then you can get the integer address. Any questions for this method? It's quite simple, right? Yeah, great. So that's the exploit sketch. So you know the address, just put the shellcode and then put that address at the return address. And then I will post a slide in the middle of like the when you guys are eating pizza. Yeah, I will post this slide so that you can take a look at the how I like the write the exploit for that specific challenge. Yeah. This is the first challenge of we have like a two set of the challenge for week 3, writing shellcode and using shellcode. So this is the solution for the first challenge. So please, so if you have a little difficulty on dealing with the program, please use this as a template for your like the exploit. Yeah, I'm okay with the copy and paste all my code. Yeah. Okay. So you can see like how it goes here. Then next thing is the next challenge is that like so I shortened the buffer size as a 4 byte. Then you cannot put entire of your shellcode. Yeah. In that case, where can you put the shellcode? So one of the way to putting the shellcode is like we can put the local variables such as buffer. That was the previous method. And then there are some other way that we can put the shellcode in the stack. And then stack is used for local variables and then storing these control data and then passing arguments. And then there's an argument that you can pass to the main function. Then how can you do that is, so the definition of the main function actually gets the argument vector. So that's actually like if you have a program A, and when you run the program /A, 1, 2, 3, 4, 5, then these are actually the program arguments. So that those kind of arguments will be passed to the main function, and then that is also on the stack like this. And then let's take a look at how Linux or other operating systems are very similar. Yeah, running the program. So when we run the program, we must use execv system call. That's only one single point that we can run the program. And then in that part, we need to put the program path, and then we need to put the argument vector, and then we need to put the environmental variable, and then all these things will be put on the stack before running the main function. So if we can inject some of the things here, then that will be on the stack. So the straightforward answer is we can put the shellcode in the argument vector and also environmental variable. And then what these argument vector means is like so sometimes we run Python a.py with the 1 space 2 space 3, then that's actually all the arguments. So the first one goes to argument vector 0, second one goes to 1, 2, 3, 4. Yeah, these are how the stack is configured. So you can put anywhere at 1, 2, 3. Yeah. So put your shellcode on that, then that will be put on the stack. So that's the description for the argument vector. And then there another part, environmental variable. So this is some of the configuration of the operating system or something, so that we can change that using command line. And then it stores some of the information that what kind of terminal you use, and then what kind of shell you use, what kind of editor you want to use, and those kind of things. So if you type env command on Linux, then you can easily see what kind of the environmental variables are there, but we can change them. And then you can put any kind of string here. And I told you that we will use non-zero shellcode. The reason is we can only put the string there, and then non-zero shellcode is definitely a string. So there's no restriction that we can put any kind of shellcode in there if it is non-zero. And then, so this graphics are like you can just focus on this kind of diagram. So that these graphics are just for demonstrating how the program execution goes through. So that whenever Linux kernel or operating system kernel gets the request to invoke a execv system call, it gets the program path. So at the top of the stack, it will have, it's the bottom of the stack actually, upside down. So at the very high address, it will have a full program path. So that means if you set the program's name as a shellcode, then that'll be on the stack too. Yeah. And then it will set up all the environmental variables below there. So all these characters are put in on the stack. So you can also put shellcode here. Then you can also check these kind of values in the GDB. So if you just say x/100x ESP and then enter, 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 then you will eventually see all these variables. And then you can put shellcode there. And then it will set up argument vector. So you can also put your shellcode in the argument vector. And then the Linux kernel will find where the symbol start is. And then that is actually defined in the binary program. And to know about the address of the start, you can run the command read-elf-a. Then you will see this kind of information. And then the thing that you need to focus is this one, entry point address. That's the address of the start. So that's how the program gets started. So Linux kernel will prepare all the stack for the program path, environmental variable, argument vector, then gets into the start and run. Then that's how the main function can enjoy all the access to the environmental variable and the argument vector. And then I will post a video and the slides so you can go back to this kind of description when you get lost, and then play the slide again and again. Then you will have a more clear view of the how stack is built. So this is the address of the start, and then this is the disassembly of the start. So the start does nothing important, but what it does is it pushes. This is the address of the main function, and then these are the address of the the CSU fini init. We will learn about those details in week 6. But how you can understand this at this point is this code is doing initial setup, and then it will call libc start main. And then libc start main is not in this binary program, it's a library call. And then what that does is they know the ABI of where the argument vector and the environmental variable is, and then eventually setting up the arguments, and then they will call this address. That's the address of the main. So so when you get to the reverse engineering, do some of the program, and then if you get lost about finding the main function, please memorize one thing. So try to find the libc start main, and then last push to the argument to the actually the first argument of the libc start main is the address of the main. So that's how you can find the main function, even if there's no symbol at all. Any questions? So what libc start main is doing is like the linking all this stuff and then call main. That's it. So so the first challenge, there's no restriction. You can put the shellcode on the buffer. And then the next challenge is a Stack Overflow use environmental variable pointer. So it's very explicit. Yeah. So your buffer size is just 4 bytes. Don't ever try it on that. And then just use the environmental variable to put in your shellcode. Yeah. And then how you can do that is like with the env dictionary on the pawn tool, you can do that. Yeah. And that's one of the method, so that you can follow this kind of the graphics. And also another challenge is called like so yeah, this is the how you can put the shellcode in the environmental variable. So you can create the env listed dictionary and then supply that into the pawn tool process argument. Then the pawn tool will put the shellcode on your environmental variable and run it. Yeah. And then your question might be, how can you find the address of the shellcode? Yeah. And then I will tell you one easy way. So just to try to make the program crash. So for example, after setting the environmental variable, what I send is just a lot of A's and then it will crash. Then it will generate the core file. But the reason why I insert the time.slib is that there is a little bit of delay. Yeah. So the wait until core file comes in and then get on there. And then from the core file, you can find the exact location of the shellcode. Then you can use that as a return address. Any questions for this specific method? So this is the result of the execution. So you can see that where the shellcode is. Yeah. And then this will be the hint for the challenge. And then I will post the slide right after I finish the lecture. Yeah. And then the next challenge is that the Stack Overflow no env. Yeah. Challenge names are very explicit. So this is the source code. And then I intentionally insert like the removing all environmental variable as a 0. So I wiped out all the environmental variables. No matter how you put the shellcode in the environmental variable, they were all 0. So you have to put your shellcode in the argument vector. Yeah. Then what will be the next challenge name? No environment variable, no argument. Yeah. And then I told you the name of the program slash like some of the shellcode. Maybe if we run this program, this program's full path will be at the top of the address space. So you can. So do you know what is the concept of the symbolic link? Yeah. So I will teach you while you are taking pizza. Yeah, I will teach you about that. So you can change your file name while you are executing actually the same program. Yeah. So it's something like a shortcut. Yeah. So whenever you create a shortcut, then you can have like icon in the desktop, and then clicking that will execute the same program, right? So that we can do that, and then you can actually name that file as your shellcode. But the problem here is that when you're writing the shellcode, if you have a slash in your shellcode, you need to create the directory for that. So I highly recommend removing all the slash from your shellcode. Then you can easily put that as a file name and then find that in the stack. So what I mean is, so for the environmental variables, they are here. Argument vectors are here, but that challenge wipes out all these things, but not this one. Yeah. So you need to change the program's name to that, and then please don't copy the program. If you copy the program, then that will be the losing the privilege. So you need to use the symbolic link, and then I will tell you how you can create it. And then it's very simple. In Python, it's os.symlink, so I will show that later. So there's the thing, and then so the other challenge is a little more difficult. Yeah. So it says Stack Overflow where I will not give you hint on the name. Yeah, but what it does is like it will check the return address. So what it does is like at the end of the execution before returning, so it will fetch EBP +4. That's definitely where the return address is, right? And then get that value, and then if that value is not in the range of 8048 something, so that this is a code address region, not the stack, then it will exit the program. So what that means is that if you try to point any kind of stack address for the return address, it will exit. It will never return. Then you need to think creatively to how can you still return on the stack by bypassing this kind of defense. Yeah, this is class is cyber attack and defense. So like I'll insert a little bit of defense, but you can. I'm sure that the most of you can easily avoid that. Yeah. So that's why it is called as a Stack Overflow, where you need to think about like how you can. So the straight answer is like you can still put the shellcode on the stack and then you can return to that, but then you need to think about how you can bypass this guard. And then the next one as an extra credit challenge is so-called the Stack Overflow where 32.2. And then what it does is, so when we start the main function, there's an argument count, and then from there to the top of the stack, I will remove everything. But you can still put shellcode on the stack. Yeah. And then this challenge is a little difficult. Yeah. This is quite weird. I always say it's easy, but yeah, this is a little difficult. But so like if you want to challenge on this, please think very creatively, and then also you need to lead us some of the documents about like how the loader works. So that's why I put the hint as a LD. And then if you read some of this document and then learn about like how the environmental variables of what the loaders are using, then you will see some of the magical method that you can put the shellcode somewhere in the stack. Yeah. Then as far as I know, only 7 students finished it among like how many students I taught in this class for this course? Maybe 80, 90 students. Yeah, only 7 students can finish this, but I believe, like this cohort is the best. Yeah, I will see like more students can finish this study. Yeah. And then another tip is like we can put the shellcode on the stack, and then to run the shellcode, we need to have exact address to run the shellcode. No, that's not true. We don't need an exact address. But let's see how we can do. So suppose you slightly change your stack, then you might point to somewhere up front of the address, then it will fail to run because this part definitely not a part of shellcode. And then if you put the return address in the middle of the shellcode, it may miss get EGID, set regid, or starting from somewhere weird, it doesn't conforms to the entire shellcode. Then how can it make it like a finding address or like having some of the what is that guard for the having a little bit of incorrect address is that it is so-called, there is a technique called the so-called NUP sled. So what that means is that So there is an instruction called knob. That's no operation. It does nothing. And then that's the bytecode for opcode for that is 0x90. So how you can put the shellcode is not just put the shellcode, but please attach a lot of knobs in front of your shellcode. Then let's see how it will be executing. So if you put the right address, then it will run the shellcode. But in the middle of shellcode, it will fail. After the shellcode, it will fail. But what if you return an address, put here? Knob, 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 and shellcode. Right? Here. Shellcode. Yeah, that's why it is called a knob sled. We are lighting a slide of the knob, and then it will eventually get to the shellcode. So like what I recommend is like put the 10,000 of the knobs and then like put shellcode, and then you can put FFFD, DDDD. Yeah, it will work. You will see that. Yeah, it's something like this one. Yeah. So please be the beaver, write the shellcode, and then nom 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 nom, something like that, and then it will eventually get to this shellcode. Yeah. So how you can do that is very easy. So 0x90, this, and then shellcode. That's it. Yeah. Oh, I have some slide for some of the tricks. So you can actually, so the symbolic link is like creating the alias of the file. So like many students ask about like oh, I need to prepare the /bin/sh, and then that requires at least 7 bytes. And then how can my shellcode shorter than that? Yeah. And then I always reply that you don't have to use BNSH. You don't have to use BNSH. Think out of box. Yeah. So this is how you can think out of box. So if you run the command, ln is like a linking something, and then -s means like creating a symbolic link. And then what that means is like actually we want to make a running A is equivalent to the running BNSH. Then we don't need the string BNSH, just A. Yeah. So that's the one of the trick. But another thing is like you don't actually put A in there. So at the time of running the shellcode, if you have any kind of valid memory address, then you can use that and then take a look at that and then make that as a symbolic link. Then you can run BNSH, and then that means like you don't have to prepare any kind of string. Yeah. And then, so for the short shellcode, ASCII shellcode, alphanumeric shellcode, so to make your life easy, what I recommend is like that. I don't ask you to write the generic shellcode. Yeah. So students ask like if I say like you don't have to run BNSH, then oh, this is not generic. So I always told you there's no right way for hacking. Yeah. So what I ask you is just seal the flag. I don't care. Yeah. Hack the computer, or I also introduced Rudy about like a different method. So like if he go to the big room right next to the GeForce Cafe in the Cali, and then if you break the wall, there's a data center, and then my VMCTF 123 is hosted in there. Yeah, and then get there and then plug up the SSD, and then you can get all the flags. Yeah, that's a good method, but I don't recommend that. You might having an interview with the Corvallis police, so you don't want to do that. So please don't do that. So, but what I emphasize is like in this class, I will let you use any kind of method. Yeah, but don't harm other students. So that do the very fun things, and then and then think out of box and then think creatively. Yeah, if you can, steal the flag, then I'm good. Yeah. So you don't have to restrict yourself to like your shellcode need to be generic. Yeah. So one of the tips about like getting a super short shellcode is for the short shellcode 32 in the main function, so that this is the place that it will load the shellcode and then run on the shellcode. So that you can set the breakpoint at there, and then to get into there, you need to do SI step into. Then it will start running your shellcode at this address. But can you see some of the register values are here? So if you need 0, you don't have to create it. Just reuse EBX. And then if you need some of the string, just use this address. So if I want to set the first argument of the exec VE as a string, then what I would do is to push ESI and pop EBX. Then this is the value, and then this is the valid memory address. So starting from here, 0C24, AD, FB, something, 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 there will be 0. And then that's actually the string. And then you can create the symbolic link, that name for the bin sh. Then we can reuse that. Yeah. And then another thing is you can actually use the similar trick for the using shellcode for the short shellcode. You can actually put the full of your shellcode on the stack. You can jump on there. That's also possible. So that's why I always think out of box, think out of box. And then that's how we can get 2-byte shellcode is possible. So please challenge yourself to that. But yeah, please don't do like the spending all the time in this class and then skipping the homework for the other class. Other faculty members would complain to me. So yeah, that's the thing. And then there are some hints for the alphanumeric shellcode. And then I just want to give you a little bit of intuition. So in 32-bit, we must have a CD80. That's how we can call the system call. But that's non-ASCII, non-printable, non-alphanumeric. How can you do that? So you cannot put some of the raw bytes in the assembly code. So what I did was like you can put 32 and 7A, 0 and Z. These are alphanumeric. But your shellcode can convert these values into CD80 at the runtime. So what you can do is you need to prepare some alphanumeric code. Then this is 0 and Z. And then while executing this code, if you can create FF and then XOR to that value, it will be CD. Do that again. A, and then eventually it gets to here. And that's CD80. And then this is called a self-modifying code. And then this is the technique that the malware writers are using, because at the time of the checking the shellcode, there's no CD80, it's all English character. Oh, it's not malicious. That's what most of antivirus software is doing. They're searching for the CD80 bin sh or something. Yeah, but they will never find it without running the thing. Yeah, so you can practice avoiding the antivirus by doing this. But I know this is difficult, a little difficult, so that's why I set it as extra credit challenge with the 250 points. But if you get to the point, then I believe it'll be easier than Stack Overflow where 32. Yeah. And then these are some of the helpful instructions. So we can use a lot of things, push, pop, and then these kind of thing, and then pop A, because pop EBX is not allowed, because that's this bracket character. But instead of that, you can use pop A. Pop A means the pop or 8 registers. Yeah. And then increment, decrement, and then XOR. Yeah, you can use those instructions. Yeah. And then this is the magic instruction that I use, XOR AX with the sum of the location over EDX. And then to do that, you need to put the EDX as a start of the shellcode address. And then you can apply XOR to change 0 and Z to the CD80. Then as a result, you will see some of the speakable shellcode. So this is the bad example, so you can ignore this, so that you can speak out your shellcode. All right, this is a lecture for today. I will take a little longer than I expect. Yeah. Right. Any questions? Sorry that I didn't update my slide. Yeah, I came here late, so so the due date is like the February 8th, right? Yeah. So. Any questions? No. Then let's order pizza.